And I think we can start and hear from Patience. Patience.
Oh, sorry. We are happy to have each one of you on this call today, and you're very welcome. Yeah, as Ronald mentioned, I'm one of the presenters in this webinar, and I'll be taking you through the first part. I'm part of the network operations team at Renu, and specifically, yeah, I'm a network engineer. I think I've interacted with some of you, and for some of you, maybe not directly. Usually, yeah, you get to the NOC, and then the NOC maybe sometimes to me or the team that I belong to. But all the same, I'm really excited to be part of this webinar and to share with you this afternoon. So I'll go straight to, if you allow me, maybe I'll turn off my video and then share my screen. Okay. So are you able to see my screen? Maybe if someone can text. Okay, okay. Yes, so I'll take you through the first part, which is maybe things you've heard about, just maybe to emphasize, and just in case if there are things you haven't heard about. Yeah, the network asset management. And I'll just introduce the topic. I'll talk a bit about network design and also about network documentation. And then my colleague will cover the other part, which is, which I believe will be the more hands-on part and which you might be looking forward to. Okay, so to start off, so I pose a question. First of all, this being a NOC webinar and targeting you people, you may be wondering, so why is Renu actually focused more on our networks? Yeah, but I think we might all agree that your campus network, or if I might call it your institutional network, say institution to be inclusive of everyone, because not everyone is from the university, like here, everyone refers to university as campus. But I think we all agree that your network is really the foundation of, you know, everything that happens in terms of internet services, in terms of research and education, which is our space in this case. So we believe that your institutional network should be a main focus, because even if your service provider or the endren, which in this case is Renu, has the best network, but your institutional network is not up there, then you will never know how good your upstream network is. So like I said, I think we all accept or agree that your network, your institutional network, is the foundation of all service, is the foundation for all the research and education activity, and also the foundation on which all services are provisioned on. Yeah. So then I also brought out some goals here for any institutional network, which I believe your network goals or maybe design goals are not anything less than this. First of all, now I think the talk now is mainly around reliability. Everyone is looking for a network that can be dependable. We are past the days when your internet connection would be off for a day and it would be okay, right? We are past days when people had, maybe only one link. We don't want to even be off for an hour. Maybe that's too much, even 30 minutes, because as COVID has taught us, many things have moved online, meetings are online. So people being off of having no connection for even 30 minutes means a lot. So we are designing institutional networks to be very reliable. Then performance. Now, when I speak about performance, actually one of Renu's core values is service quality. So in designing networks, like even down to your institutional networks, we think that you should be focused more on how your network performs, yeah, on the quality of service that your network is able to provide to the end users. And then I come to manageability. Thankfully, you're the people that are the network admins, the system admins. So you're the people managing your institutional networks. Yeah. So this is focus. I mean, we should all have networks that we can easily manage. Yeah. That we know where is what, we know which VLAN is going where, we know which IP is where, and that way we are able to manage. We have credentials to the devices that are on the network. And then another important one, scalability. So so scalability is very important, because I think sometimes people look at, maybe today you have a small network that is just in one building, but your institution is growing, yeah? So you should, as you design your network, you should have in mind that there is room, you should plan for room for growth, because you don't want to have another building and then all of a sudden you're changing switches, because initially you planned for one building, you had 12 port switches, you didn't envision that at a later time, you would actually require switches with more port density. So scalability is very, very important. And even for services, I mean, every day or every other time, Renu has been reaching out saying, there's this new service from the old days when they were singing about EduRoam and stuff. Well, we are still singing about it, but there are many other services that have come up. So are you designing your network to scale in case of something new? That is something very important. So I thought that any network, any of your networks should not, any of your network goals at least should not be anything less than this. You might have more goals, that's okay, but we believe that it should not be anything less than this. And now when we look at network design, and actually some of you that have attended our capacity building programs, and especially the campus network design module or track, this is something that we emphasize a lot. Yeah. So first of all, we say a good network design should be modular and hierarchical. Modular in that you know that this network is in this VLAN, it's here. Yeah. This flow is in this VLAN, it's here. And hierarchical in that, you know, like you see on my screen, the diagram, you have you have the access, yeah? So all your end users are connected behind your access layer, if I should call it. Then you have the distribution, yeah? The distribution part is, so you don't expect to have your end users connecting behind your distribution switches. They should all connect here. You see, what I'm trying to build here is some hierarchy of sorts. And this is what we propose or think is a very good network design. Because remember, from our goals, we say it should be easy to manage. So if you have a network that is hierarchical like this, then it is easy to manage. You see the core is at a different level. You come here, your border router connecting to the CPE, which is usually the switch that Renu gives to you, actually all the time. And then this switch here connecting to Renu. So this is the design that we recommend. We know that this, of course, also poses some budget, comes with some budget constraints. And this is something that some of you raise to us all the time. But in, I think, many cases, Renu has been generous enough, of course, working in partnership with some other partners like NSRC, to extend to some institutions that have come to us and requesting for assistance, maybe in terms of switches, to enable them actually have their networks this organized. So maybe someone might be wondering, so how does this hierarchical network make managing it easy or better, Because think about if you have, suppose you have maybe quite a big network and all these switches are like, so each switch has like a separate VLAN, so it's a separate network and maybe on a different floor or different building, regarding on how your campus is organized or your institution. So should you have a problem that is in that building, then you know which VLAN exactly to look at. You don't like start from the top, because now that is high level. Yeah, the network would be too big for you to come down to the actual problem. So what this helps you is you actually dig down, you easily dig down to where the exact problem is. And I think that's important in terms of it saves you troubleshooting time. Yeah, because right away, maybe you know where to start from. And yes, of course, it makes it easy to manage your network. Going on. Yeah, so basically here, this just is a summary of what I've been saying on the previous slide, where I'm saying separate layers of the network. I route here, I do the netting, and all these VLANs at the core. Then at the distribution, I'm just distribution and the access, I'm just switching, stuff like that. And then I say build star networks. Yeah, star network. I think if we come back here, you see the kind of star here. Yeah, or even just starting from here, from your core switch. Then use standard solutions for common situations. So there are things that happen all the time, and maybe every time you've raised it with the NOC, they will tell you do this and it solves that. So things like that, there's some things that are standard, if you see your fiber lights off, that is if your last mile is fiber, If you see the fiber lights off, you know this is a physical layer problem. So you don't waste time now going to the access, going where. That saves you also troubleshooting time. Then provision central services near the core, route near the core, switch at the edges. I think I mentioned that. Separate the core router functions from border router functions. Okay, that's really all about having your networks hierarchical. And then I've been looking forward to speaking about network documentation, because I think for most of us, this is the problem. And if I were to pose a question to each one of us, I don't know how many people actually have like proper documentation of their network in terms of network diagram, network resources. Do you know which IP is where, which IP pool, public pool is netted to which private pool of IPs? Do you know you have all credentials for your devices on the network? Yeah. And as network admins in all our institutions, this is a very important part. Yeah. Because how will you manage a network? How do you even manage a network that you don't know how it is laid out? Yeah. For example, do you know that from the CPE is just the Renu switch, customer premises equipment, the switch that where you handshake with Renu, from there, where do I connect to? And then how does the network actually spread out to the final end user? Yeah. Then do you know what devices on your network are doing what functions? And I think you've encountered some of these questions with maybe Ronald or other people in the NOC when you're trying to troubleshoot with them. So I ask you, so which IP do you have here? You know, and maybe you have no idea because you don't have this documented anywhere. And you don't want to begin looking for things at a time when you have an outage and you're fighting to have the connection back up as soon as possible. So this is very, very, very important. Network resources, VLANs, IP addresses. So usually at connection, we have, Ren will tell you, this is the IP that, you know, the point IP, this is what you need to point your default route to. This is your public IP space. This is, yeah, IPv6, IPv4, yeah? They'll probably write for you those things and you sign off. But where do you keep those things after? It is important that you actually keep track of this and you know which IP is where. And even beyond this, because now I've just talked about public IP addresses. I think there are a few of us that have our entire networks running on public IPs. So you have private IPs in your networks. But which private network, this is for segmented networks now, which private IPs, the block, is netted to which public IP? Do we know that? Which network is netted to what? Which VLAN is for this staff network, or is for the finance department, is for the technical department, is for the wireless network? Yeah, you see, these are things that we should not simply keep in our heads, because maybe today we are there and next week we might have changed somewhere else. So these are things that we should make sure we actually hand over, and we even work with teams. So these are things that you as a network admin should not keep to yourself, because they will cost you time at the time of troubleshooting. I think the most interesting one for most of us is the access credentials. I know this sometimes comes with some trust issues, but I won't talk about the trust issues for today. But I don't know how you can manage a network and you don't have credentials for the router, for the switches. I mean, it's hard, because what will you do? if the switch is up, it's powered, yes, yeah. But maybe you can't go past your router. You want to log in and see what configurations are there, but then you have no access, yeah. So I would like to encourage each one of us to ensure that we document our networks for us, for the teams, pass on knowledge to your juniors, and then they will help you in times when you're not there. They will actually get to help you. So speaking about the network diagram, I got an example from one of you, could be probably on this call today, but they didn't allow me to mention them. So this is how the network looks like. So basically, this is Renu, the cloud. They don't know what happens in Renu, so hence the cloud. So they have a connection to Renu. Here, there's a patch panel there, then they go to the switch. You see, they say ISP router, they have a border router, power router, distribution patch panel. So they have fiber going to other buildings and what. Okay, so looking at this, when I first saw it, I was like, wow, this is quite confusing. This is a bit too much, yeah? But maybe because of how it looks here. But because he has this, because he has his network in a diagram form, he is able to understand. If you ask him, where does maybe Pastor Vitamazire, the link, where does it connect? This will help him to actually follow up, just looking at this and know that, okay, so there's a fiber connection to this point, then it comes to this switch, then comes backwards here, then the fiber goes all the way to the distribution switch here. Yeah. And I think this would actually help him if he was dealing with any issue that is, like this far. But if you imagine you run or manage such a network, but you do not know, but you do not have anything like this, yeah? So it would be quite difficult and it would cost you a lot of time actually to come to resolve any issues. And yeah, I think we might agree, because looking at this and someone at this hostel here tells you that you have no connection, you may not have a starting point if you don't actually understand how your network is laid out. Yeah, I think this is what I have. I don't know if I think Ronald will guide us. I don't know if we'll have the questions now or after his presentation. Yeah, but thank you for listening to me.
Thank you, Patience, for the presentation. I think it's been elaborate and everyone here was hearing you loud and clear. There are some comments here on your presentation, just a few. Someone is commending your point on documentation of the network. So they are very appreciative of the fact that when we have proper network documentation, things are easy to manage, especially when we talked about managing of our devices. Jackton loved the presentation. Ismail says it's a nice presentation. Justin, thank you. Hakim, David, and yes. Now, I think if there is any question or any concern from the presentation, I think we can have some raised in the chat, or if someone wants to say something, the team will be able to allow them speak. But there is a question from Namataka Scovia. I think she's from NCRI, Bali. She says, which software can be used for documentation? Patience, do you want to take that?
Okay. Thank you. That was from Scovia. Thank you for the question. So documentation, actually, I forgot to mention about the different configurations that you have running on your devices. That is another documentation, because you don't know when that switch will die. And also starting out, looking for what config line was where may be difficult if you're trying to beat the outage time. So there are tools for that. Like there's a tool called Rancid, which polls your devices and picks the configurations. Yeah. For that, you can reach out. You can write to the NOC if you need assistance on that. We will, of course, definitely need a server where you can run that. Then the IP, or if I should say the network, the IP resources, yes. You can just have your Excel, yeah, in a central place where everyone can access it. Drawing these network diagrams, there are tools like, I think the one I've used before is iDraw. You draw out your diagram neatly. I'm sure there are others, maybe even the participants here on chat can be able to share with us some of the things that they use. Sharing is actually the NREN spirit. So some of these things that we talk about, if you're using them in your institution, feel free to post for other guys to learn from you. Thank you.
Thank you, Patience. There are responses here on the chat. People have suggested iDraw, Rancid for configuration management, then Oxidized as an alternative for Rancid. Someone uses MS Visual, then DIA, then iDraw. Those can help us get network diagrams. Yes, someone wants to say something. I think this is Gift. Okay, Gift, I think you are allowed to speak. You can unmute and speak.
Oh, good afternoon, and thanks for this chance. My name is Gift. I'm representing Metropolitan International University. I had a concern, like I wanted Patience to elaborate more on documentation and password policies, like she mentioned about that, the best practices. Like, how do I keep these files? Do I keep them separated somewhere? Let's say I'm dealing with organization information. Must I keep it on a separate file that is well known to me and shouldn't expose it to my juniors? Because I have a feeling my juniors shouldn't be knowing each and every information about the devices. So do I have to put it in a place and share it with them so that they can have access in a way that when I'm not around, they can easily step in and assist? Or it has to be on a separate storage where I have to like pick individual access details?
Thank you, Gift. Your question is ably, and your concern. I think as best practice, you should document everything you have, and whether you give it, you give access to whoever your organization policy or something like that, but you ought to document. The fact is you document in case you possibly you become VC or something and hand over, there is someone to hand over to and something to hand over. I think patients can add something to that.
Yes, thank you so much for raising that. You see, I mentioned that we are now very concerned about reliability of our networks, yeah? We have many concerns from you people saying, okay, now we need a backup link. We can't afford to be off even for a minute, even for 5 minutes, yeah? But now, I think we should also look at it in terms of the personnel. I mean, there is going to come a time when you are not there. Things happen. I do not want, I mean, God forbid, but we have had cases where someone was the only one, that had all credentials, and unfortunately they passed on. So what happens to the institution? So, I mean, such cases, maybe you can have other controls in place. If you don't trust your team, that is, maybe you're the head, you have the junior team, but you don't trust them. You think they might go and mess up the network. Maybe you can have a logging, I mean, like a way to log in, to log their access. Like if someone makes a change in the device, you get a notification. So if it was not authorized by you, like, I mean, because I don't expect that your juniors will just go and put some routes in your router and the team has not discussed about it. It's usually things that that you should know that are necessary. But my point here is no institution should really have one person that has everything. We need backup in everything, not just for our links. Thank you.
Thank you, Patience, for your response. Yes, someone made a comment. Thank you for the presentation. Truthfully, it is disturbing when one loses access or when one looks for access credentials of a certain device and they cannot find them. It's disturbing and it's not nice and it shouldn't happen. We have someone, Obirakol Muzamiru, you are allowed to speak. And then we shall take one more question and proceed. Muzamiru, you are allowed to speak. Please just unmute and speak. Okay. Let's hear from Faith. Faith Obot.
Yeah. Hello. Hello.
Yes, Faith. Yes, Faith. You can hear you.
Okay. Thank you, Ronald, and thank you, Patience. This is Faith from Lira University. I would like to thank Patience for her great presentation. It's something that we take for granted, but I think it's really important for us to document our network. My question is, we've been wanting to draw our network and maybe place it in offices. So my question is it safe that way? That would draw the network and distribute it in offices for people to know the network of the university. Thank you.
Thank you, Faith.
Okay, thank you, Faith, for your question. I don't know when you said, I don't know what you meant when you said distribute it in offices, because I think the network diagram should really be knowledge for the IT team, your DICTs, Directorate of ICT for a university like yours. So I don't know if you mean that you go and share with the finance people, like this is our network is connected, maybe share with, I don't know which other department, but for me, my proposal would be your team, your ICT team should all have knowledge of the network, because in most cases we see that different people are on call on different days or different times. Yeah, so if it's just two of you who know, and then someone else is on call, then they may have to disturb you on take leave. People are calling you, So just for the IT team, because you're the people that support the network, the others may not actually get to appreciate the relevancy of the diagram. I think it makes sense to you, the IT people. Thank you.
Thank you, Patience. It's clear.
Thank you, Patience. Just a few comments. David says, storage of device information, password, access rights is largely based on your ICT policy. So yes, you have a policy in place. If you have one, then some of those controls in the policy should guide on what to share and what to, for example, publish or print out or things like that. So of course, in the policy, all those details can be added. Now we have Gashom. He says gifts. He says gift, you get the documents and give it to upper management and you report. Okay, to safeguard the institution. Anyway, I think you can read from the chat and see these are reactions to. All right, we are going to proceed to the next presentation.
I think someone in the chat was asking for the presentation. I think we'll be able to share this, even the next one. So we'll share all of them at once with you all after.
Thank you, Patience. I think we can proceed to the next presentation. I'm going to share my screen. Okay. I believe you can see my screen. Okay. Now, in the next part of the webinar, we shall be looking at basic troubleshooting. What we have seen in the past are that this industry is dynamic as life is. We have institutions that start with one member of staff or one member of the IT team or technical team. And after 2 years, they have 5 members. Those members possibly are not at the same level and haven't been possibly taken through the basics that run and help them guide how to manage their network. So that's why that is one of the reasons that we tried to come up with this webinar. So we are calling this basic troubleshooting because we shall just go through them quickly. And we believe that possibly have seen these tools and have seen some of those things. But we want to reach out to even those that haven't been able, say, to join our Renu capacity building workshops and other technical platforms where they can learn some of these things. So everyone is saddened when they have no service, whether internet service or any other services. So your website is down or unreachable, or you can't upload files to your site, or any other services. It is really not nice, and we know that some of those things practically affect operations. So in troubleshooting, we usually do go through a few steps. So the day, for example, Faith from Lira gets a call, maybe she's home on a weekend, and a member of staff or a student of the university calls them to say, hey, our internet is off. So where exactly does Faith start from? So usually we have seen some of these things, and the challenge is that some people are committed to troubleshoot internally. Others will call the provider, they'll call Renu. So usually some of the challenge is not that they are fast at calling Renu, but possibly some of them do not know where to look, or do not know how to, where to look and what to look for in case there is an outage. So there are standard procedures that you can go through as you're troubleshooting and looking for faults or outages. And these we have, possibly you have seen before, or you have encountered. And what makes us better as humans is we learn from every experience that we have. So before I go any further, I'm opening the chat room. What are the common network problems? I think we can start from there. What are the common problems that affect our networks? You can share in your chat just a highlight or a list of some of those that either are common to your institution or common to people that you have interacted with. Yes, someone says power outages as one. Another one says latency. Another one says low bandwidth, power blackouts, power outages, packet loss, rats invading Ethernet cables, fiber breaks, internet or network intermittency, overload of the network, slow network, low speeds, weather, DNS issues. So these are actually common large applications, physical connection issues. power goes off and one switch loses connection in addition to low bandwidth loops. Ismail. Fiber breaks, outdated devices of the network infrastructure. All right, as you proceed, interference on wireless networks, as you proceed with listing what you have experienced, these are common challenges and we have seen them. The challenge is, do you acknowledge that there is a problem here? If you do you have a way of trying to mitigate, trying to see if this has happened today, have I learned on how to solve the problem the next day if it happens? So this is what makes you or me a better person as we manage our networks. So I've just listed a few here, loss of connectivity, including fiber breaks or equipment loss or power loss, high packet loss, unable to send mail, something like that. You can't reach services or servers, or even just a small part of your network. Now, as we do troubleshooting, we should never forget that troubleshooting is hierarchical. It is a step-by-step process, and it follows a particular order. You come from, and I think this can guide us, every one of us possibly knows the 7 layers of the OSI model. They have seen them and possibly have worked with them. In our normal operations, possibly we can start with the physical layer. On the physical layer, this is where you have your physical equipment, cables, connectors. Basically, before actually we look at these layers, do we have power? Our equipment powered? You know, an institution possibly has, let's say, gift is called while at home or something, and the vice chancellor is in office, and there is no internet, you know. So where does gift start from? Maybe in the server room, which is a separate block from the administration block or the office of the VC. The equipment has no power because either of a breaker tripping or something like that. So at that point, when gift gives a call to the Renu Noc, you know, the Renu Noc will see, yeah, no problem, because we can reach your equipment, and at that point, because the VC is interested in seeing service up, you know, it is the job of gift to run possibly to the institution and find out exactly where the problem is. So on the physical layer, after we look at the power and our equipment are powered, do you see that your lights on the equipment, your light connection to the routers and things like that are intact? Yeah. Some of our server rooms in public places talk about kitchen areas or past the server room. The campus didn't have a lot of resources, so the equipment is in the computer lab, especially for schools. And students are passing by, and someone trips over the cable and it comes out of the switch. And then, so do you know exactly how to sort this? If you go to the next layer, you know you have access switches, and they have particular VLANs. So this switch has a VLAN for access, and possibly it is connected to the student's lab. This switch port is connected to the printer. Yeah. And then someone goes to clean the server room or something like that, and then they remove a few cables. Are you able, and this is actually informing us in the previous presentation, that if that cable to the printer is out of its port, are you able to locate that, oh, the port on switch or the switch port on switch port number 21 is actually supposed to go to the printer, because you're going to have a VLAN for printers and it's allowed to do printing. But if you switched that cable to port 22, it is not able to do that because it is not allowed to. So, and then on the next level, you see we have tools and we have IP addresses at that point. That do we have reachability? First of all, do we have an IP address at that point? Do we have, can we reach our gateway? So this takes us step by step. So before, say you go to accounts department and they say, hey, call you and everyone in the university has internet or a connection and the accounts office has no internet. Where do you start from? You know, so they are not going to start from power or anything like that. So at that point, this step-by-step process will guide us in, first of all, identifying the problem. So the problem is that the accounts office has no connectivity. And then establish a theory of probable cause. Everyone is connected, so it's not Renu's problem, or it's not the provider's problem. So there you're narrowing down, you're isolating the problem step by step. At that point, you don't have, possibly if you have your documentation ready, the first thing you're going to check on is if the entire accounts department is off, then where do I go? I think we have a switch, which we called in our diagram, the core switch, where we have a connection that leads to the accounts department or the accounts switch. So if that cable is connected or something like that, possibly that was the problem that you had to sort, and all that can, if you have the information that only the accounts department is off, and possibly it's their cable that has a problem or something like that, you troubleshoot the issue within no time. So anyway, in step 3, we said we are going to have a theory and we are going to test it. So by testing, like in accounts, possibly it's not a physical problem. The switches are, the cables are intact and things like that. What about the access switch? It's powered. Does it have configurations? Can you reach through that port from the access switch of the accounts department? Can you ping your gateway? Things like that. So there you have established a theory, and then you go ahead and take action. You begin practically testing, isolating the problem step by step. Then the next step would be to verify your findings or what you have tested and your hypothesis. So you verify, and possibly it doesn't work, proceed to the next step. It doesn't work, and possibly maybe you need to ask a colleague who has, maybe you need access credentials to the switch, see if it's working fine, if it has the configurations allowed to pass the VLAN to the access people on the accounts department. And then, of course, after all this, possibly you have solved the problem. Are you able to document your findings? And in this, we always talk about if you have visited websites and so much, you see, especially equipment providers or vendors or things, they'll have a knowledge base. So the knowledge base can be, it is something that you learn over time, out of experience, that today I had a problem with this. Maybe the switch malfunctioned or the switch lost configuration. And what was the problem? And how did I sort the problem? So by doing that step by step, you're documenting, and then you have a solution and you document it even for those that follow you. Now, from the model that we have discussed, the OSI model, we can look at a few layers which mostly affect our performance. when managing our networks. We have talked about power issues, and people have listed power issues as one of the biggest problems. Power issues may not actually affect just the users or something like that, but it could affect the devices. So we have institutions that have, they are connected to the national grid, but they are possibly their transformer is overloaded or something like that. And their power, it's either low voltage or things like that. And they connect directly to the switch or to the equipment. They are not able to have regulators or UPSs. The problem is that these devices, these network devices or computers have particular thresholds. So some of them cannot handle those so many power interruptions or power fluctuations. So we have experienced some devices, especially CPE devices, Juniper, MikroTik, and things like that, which we deploy in our network as edge devices for us, and then CPE devices. So these devices are critical. They work when the power is stable. So when the power is stable, they will work fine. They can even run for a year or so without being interrupted. And we have devices that have never been powered down and have no problem. But when we have those power fluctuations, because they have modules within them, that those files, sometimes it's like you're commissioned. I believe you know how, for example, we were advised to shut down computers or devices. You commission, say you are the Inspector General of Traffic Police or something like that. You commission your officers in the field, and one is at Wandegea, one is at Kamocha, Abwaise, you know. So they are working and they listen to you, and you know, you're the central system. So when power goes off for our devices, you practically abandon your officers in the field, you know. So when that happens, the devices sometimes, especially when the power goes off, they take time. When power comes back, they take time to try to remember exactly where the files were. So if during that process, because our devices take about 5 minutes, 5 to 10 minutes to boot up properly, when those devices, when during that boot up process, it is trying to commission, where is this officer? Where is this? Let me deploy this. Let me deploy this. And then power goes off again within the first 3 minutes. So practically it could lead to malfunctioning of devices. I really cannot emphasize that a lot more, but most of us have experienced the effect of these power flaps or power fluctuations. So on the layer 1 still, we look at access links. We have seen, you know, practically that we have copper cables running on our networks. We have wireless networks. Do you understand these configurations and these deployments, that this switch has ABCD connections, so to the accounts department? That information still is fed or can be picked from our network documentation. Then look at the last mile connection. Most of our network is on fiber. Most of the network is on fiber, and of course, wireless, microwave, and other technologies for those that are in particular areas, depending on the footprint. So, like someone said here, we have so many issues. Our country is still growing, and infrastructure comes up every day. Now, as a network manager, if you see a building come up in your, possibly your fiber, you know the fiber, say to Lira University is aerial, let's say, and there is a building coming up in the area or on the path of the fiber, and guys are working and I don't know, you see your cable getting possibly falling down and being tramped on. Do you have, possibly as a manager, you know that this cable possibly serves us. And because it does, you ought to take care of it. And we really thank and appreciate those of you that when you're driving through or going to the institution, see some poles leaning, see some poles, because by doing that, it helps us to be fast and be proactive to resolve some of these issues. Someone said that there are rodents that disturb them. Unfortunately, rodents enjoy some of these cables, those fiber patch cords and even Ethernet cables. Now, as a manager, do you know that is your server room protected? We have seen institutions that deploy equipment on the ground. And I don't know if you really take care of things by sending us that. And we ask them, hey, share a picture, and that is if the device is off. And they share a picture and the device is on the ground. You know, it can have problems. And the problem is that the institution actually has to pay for that device in case it has possibly someone is cleaning and spilled water into the device. Anyway, at this point, we have tools that we can use, say network cable testers and network analyzers, to see that at that point, at the physical layer, the cable that is delivering connection to your access point in the boardroom or your access point to the student's Wi-Fi, that cable is fine. You need a cable tester to see the cable is healthy, and because sometimes comments can come, they say on the wired network we have no problem, but on wireless, you know, some of those comments. So that would be the first thing that you can check on layer one. But okay, if I have a cable that is going a particular span and the cable is kinked, can I first of all test and see if it is still healthy and possibly I can replace it. On layer two we have switches and MAC addresses. So if you configured your switches to accept a particular VLAN and particular functionality, then there shouldn't be a problem. Problem would be when you have corrupted packet flooding and MAC address misconfigurations. You know, at that point, you can use a network analyzer like Wireshark, which is a tool that you can freely use, download and deploy to test. It will give you a lot of detail on layer two, especially the IP address. It can actually give you the IP address, which is on layer 3, but it will give you the MAC address, that is the MAC address of your particular, the two sessions. So you're testing from your source to destination, and it will give you the MAC address of that, and possibly you can easily zero down to the nature of the device and exactly how it is performing. On layer 3, we have IP addresses. Do you have the right gateways configured for all your networks or small networks? The right subnet masks, the right device services? Is DHCP running? DHCP, are you actually manually configuring your IP addresses to the users? Are you getting a server that manages that for you? DNS, Renu has DNS servers. You know, that is a service that gives to member institutions for free. Because we run an open network, which is enabling institutions for research, we expect that the internet is free for them and they will manage it the way they wish. If you need, for example, we have institutions that are faith-based or religious-based institutions. If a religious-based institution wants, say, to block adult content and possibly gaming or things like that, you can reach out to us and we find a solution to that. Additionally, we have schools on the network, which we don't give, we practically ensure that they run a safe network, safe from adult content and those gaming sites and some of those things. They have a particular set of DNS that makes that possible, such that the kids are safe and there's no problem. We proceed to the other challenges that are within layer 3, of course, like you mentioned, slow network, inability to reach particular resources. Here, we have so many tools that we can use, utilities. Ping, which is a very common tool, very common utility, trace routes, or trace RT, trace SAT. And so some of these possibly we can have a chat and share. So most of us have seen ping. Yeah, we have used it. It possibly will show us reachability to a particular host, and the host can be within your network or on the external, say with Renu or even on the outer internet. This is, I think, the most common tool, and it will help us, for starters, to show you that I cannot go out because I cannot reach this particular host. And then we can go to the traceroute command. This will give us the path that you need to take to reach a particular destination. If you're usually when we ask you, your network is too slow and things like that, we ask you for traces. And in particular, we ask you for ping plotter traces. We shall have a slide on ping plotter, and this will give you a detail on exactly how your path is going from your institution to the outer internet. And then it gives you particular unique features that will show us that possibly at this particular node, there is a problem. So this is a sample example of a test which I ran from my machine. So here it is showing you that I'm running from, I'm trying to test to bbc.com on IPv4, and it is running up to 13 hosts to reach the destination. Here you can see that it is from your network, which is my network here, reaching us in our POP in Kampala. It goes to our external and transit providers that carry the traffic through to the outside world. So the tool still allows you to run tests to on the IPv4, IP version 6 type of the network, and of course here still we run tests. Now, when we ask you to share ping plotter examples, for example, traces and things like that, the main purpose, as you can see, we have the hops to the destination, which destination here is google.com. But particularly, I want you to be keen and look at the hosts. Sorry, look at the hosts, sorry, the hops that we are running. The very first hop is 192.168.1.1. This possibly is an access point, maybe, or a router in the network of the institution. So when you look at this very first hop, look at the average round trip time. The rough average round trip time to this first hop is 315.9 milliseconds. And you see it is varying because the minimum was 1.8 and it even reached 2000 milliseconds. So when you share such a screenshot, we try to explain to you that, hey, if this is on a wireless link or a wireless access point, there is a problem. If it is not, then this node, the very first hop, 192.168.1.1 has a problem. So either it is too congested or possibly it is running so many NAT sessions or it has CPU utilization issues. But practically, you can all see that in this highlighted green bar, that there is a 4.1% packet loss. So we don't expect when you are within your very network, we don't expect you to have, you know, such packet losses. Because the problem is that when that loss is spread through your network, you know, it is going to reach, it is going to add some kind of problem because you're going to do retransmits to your destinations. And this is up to 4% just within your network. So by the time you reach your destination, you're seeing that you are up to 8% packet loss. So we have some detail on how to interpret these graphs and possibly, and we have a blog post on that. Possibly we shall share with you. You can interpret by yourself. You can read through and see how, and possibly run your tests. I want to believe that everyone on this call has Spinplotter installed on their machine. If you don't, please do. Okay, now, other tests that we run point us to particular sections in the network. As you can see, this trace runs from hop 1, which is 10.32, which is in a private network, reaches a public, reaches Renu. You can see at this particular hop 4, the machine or the node that we have there is practically doing our bandwidth management or bandwidth policing. So if this institution from which this screenshot was taken is subscribing for 10 Mbps, and possibly at that time they were using 10 Mbps, then we shall witness a 0.3% packet loss. You can see that in the first 3 hops, there was no packet loss. And then this packet loss actually spreads out after and continues to the other parts of the network. So in case we explain to you that, hey, subscribe for 10, you are currently using 10. So at that point, because of the congestion, your packets may have to be retransmitted, and that practically leads to the slow speed experience that you have. We have seen this utility, ipconfig or ifconfig for those of us that use, or those of you that have Linux-based machines. You can see the detail here that you see your IPv4 address 192.168.2.28, and you see the MAC, the subnet mask. You see the default gateway. You see the DHCP server. you see the DNS servers listed here, and these are Renu DNS servers. So by doing ipconfig from Windows or ifconfig from Linux, these details alone can explain to you in case of any problems. I'm going to show you a simple example of an institution that was struggling with no service. But when we asked them to share this screenshot, this test from this command line utility, they were getting an auto configuration IPv4 address, which is in the subnet 169.254.00/16. And these are automatically given to hosts or machines that have not been able to get an IP address manually or from the DHCP. So because of that, we expect that as a network administrator, when you see these 169.254, there is a problem with your DHCP server. And from that point, you practically, if you have a DHCP server on campus, then possibly check it out. See if it is reachable, see if it is powered or functioning. I'm going to proceed to bandwidth utilization. Every member connected on the Renu network is given access to a tool called CACTI, which gives you your bandwidth utilization. This tool will run it tests on the interface. From, if you remember, on our network diagram, the interface facing your router, that is from the interface on the CPE device, which you call the Renu device, that is facing the institution, facing either your router or firewall. So that is the interface that we graph. And the statistics there are showing you that possibly you have an average or you have a maximum and you're currently utilizing. So this, because you can zoom in and see, okay, at this particular point in time, I was using 12 Mbps, as you can see in our screenshot, 12.73 Mbps, and then 1.4 in upload traffic. And the maximum I have ever hit, according to this timeline or time scale that I've selected, is 59.81. This is showing you a trend of performance. When you're troubleshooting and say, hey, this, at this point, the network is too slow, visit this tool. You have access, check it out and see what is my utilization at this point in time. If you, for example, subscribe for 35, and you're using 35, then you know the first point would be that the network, the user is actually using up all the capacity or the bandwidth. If you are struggling, the network is not performing well, you subscribe for 35 and you're utilizing 10 at the moment, then maybe it's not bandwidth that is constraining you. Then maybe the problem would be, and there that takes us back to our spin plotter tests. So you run the tests and possibly come up with some kind of detail, and of course you can easily share with the Renu Noc on helping you understand exactly the results. We have institutions that, let me take an example. Yesterday, you got a device or you want to test something. You get a server, plug it in, configure it, connect it to the network. And then after a few days or something like that, people complain, the network these days has been terrible, and then possibly you visit your utilization graph in CACTI, and this is what you're seeing. So if for example, as you can see in this screenshot, inbound is your upload traffic, and then outbound is your download traffic. You can see in our networks in Uganda, we are mostly consumers. We don't upload a lot of traffic. What we upload is really very small compared to what we download. But you see, for this particular scenario, this person was uploading way more than they were downloading. So there is a question. It is now, you have, for example, in our troubleshooting, we have found that everyone is complaining the network is too slow. So, okay, so what could be the problem? Can you run tests? You just look at CACT and see this. Okay, now you begin establishing a theory. If this is the problem with upload traffic, and you possibly are the one that are in charge of the network, and you remember, oh, I think because some of these things we find out after interacting with you, that, hey, we see so much traffic upload. Where is it coming from? Are you aware? Is it legitimate? Is it something that you commissioned? And then you say, no, nothing has changed. I have not touched anything, And then we say, but there is something here. Yeah. No, I was just testing something small. So usually, for this particular scenario, taking off that server immediately stopped this. So this actually was a compromised host that was had so many ports open, and it was being used by malicious people to attack the institution. We can proceed to speed tests. Most of us have seen OCLA, the Speedtest tool, speedtest.net. Some of us use fast.net. Some of us use Google. There's a Google Speedtest tool. Others use different Speedtest tools. But the question would be, do you really understand the results? Do they relate to you? When you see a download of 0.48, these people are not being honest. I subscribed for 10, I'm getting 0.48 Mbps. So, do we understand what these results mean? First of all, just looking at this screenshot, you have done a test from Renu, because this is my IP address, 196.143.159.38. Okay, so what am I targeting? I'm targeting the Tangerine Uganda Limited server, Speedtest server. So that is within Kampala. So I don't really expect a lot of round trip time. So as you can see, my round trip time to the Tangerine server is 3 milliseconds, which is optimal, which is acceptable in our scenario. Now, you see results for download and upload. This particular scenario, I may not really explain how this person got 91.51 or 95.18. But all we can say, for example, is that the capacity they have could be 100 at that point in time, or possibly they are not capped, or they can reach even up to 1,000 or 1 gigabit per second. But then, do we have a consideration of the equipment that we have? In our asset management, we saw that if you know your devices, you know their capabilities. You have an access switch which is very old. You have cables that are Cat5, but you want to achieve 1 Gbps of upload and download. Is it possible? So do you know the equipment that you have? Is there a limitation on the equipment that you have? You have a copper cable of 100 Mbps. It is capable of 100 Mbps. But possibly Renu says that within the Renu network, we say within especially Kampala, you can do up to 1 gig, you know. But for you, when you test, you can only stop at 91. So are your equipment or your cables able to push the traffic that you want? Now, speed tests are run. My machine, call it a client, will send some payload, some data, targeting the Tangerine server. So first of all, we expect response from Tangerine so that we can proceed with the test. So we get a ping, so an echo response. So it goes and comes back. So when it goes and comes back, that is fine. Then we proceed to the next step. How much data can we push through the existing link? So the payload, according to this speed test tool and their methodology, the payload is going to be sent over the network. So it is going to be sent in incremental values. So we can say we are going to send 5 or 50, let me say 56 bytes of data. Then how much time does it take for that data to go and reach the server? Then that time is going to be recorded. And because these tests, as you can see, they continue running until they stabilize. So when they send the first payload, they say, okay, now this reached well, really fine. Let us increase and push a lot more traffic. So it pushes a lot more traffic until it is saturated, and then it will return the 91.5. And then it does the same. The other server now sends you payload, and it does the same test, and then we register this upload speed. Now, the problem is that most of us, when we run speed tests, we run them when we are frustrated. So you see the network is not performing at all. So you run a speed test. So you run the speed test and you're getting a result of 0.48, and you say, these guys are taking us for a ride. But you have not taken into consideration your current utilization. So the way these tests work, as I told you, they are going to ride on what is available, the link capacity at the time. Tangerine is out of the network, though it is in Uganda, but it is in a different domain, administrative domain. So it is, to us, it is international traffic. So, and Renu, practically what you subscribe for in Renu is international traffic. So the 10 Mbps that you subscribe for is international, so which actually includes Tangerine. So at that time, when your CACT shows you that you're using 10 Mbps currently, and you run a speed test, the speed test result, don't be surprised when you see the speed test result to be less than 1 Mbps. Because at that particular point in time, your pipe is saturated. You can consider it as a pipe carrying water. The water can only accommodate, say, 30, the pipe in its nature can only accommodate 30 cubic meters, something like that. So that is the volume, 30 cubic meters. So, but 30 cubic meters at that point, if you're using 20 at the time you're taking the test, you're leaving 10 cubic meters free of space, of air, for you to push more water. So when you send through a speed test payload, it is going to ride within the space that is left. So your result will be within 10 Mbps because your pipe is 30 Mbps. You're currently using 20. So that means, according to the speed test server, the room that is available to test against is 10 Mbps. So that is why when you get that result, it's going to be less than what you subscribe for. So when we ask you, when you share speed tests, for example, you can, the best time, for example, is when you are alone on the network. You're alone and you can run your test. So you're alone, your utilization is very low. Yeah. So at that point, you can run tests and get something closer, or if not, your entire subscribe bandwidth. I hope that's clear. Now we have speed test servers. Persona is a project which is open source and a lot in the NREN world. So you can run tests, and we have provision for you some servers in our POPs in Kampala, in Mbale, in Gulu, Barara, Arua, and with availability, we shall deploy more. So when you run those tests are going to be done within, or tests against from your network too, but they remain within their own network. So that's why when you run those tests, you're going to actually get a lot more capacity than you subscribe for. Just in summary, well, I think we can just have the questions now, if any, and then we proceed with this summary. Thank you.
All right. Thank you so much, Ronald, for taking us through. I think the presentation was quite elaborate, and I think most of you could relate with it. I think these are the daily things we deal with every day, you know. And I was actually, I mean, when we asked what issues do you guys deal with, most of you raised very interesting issues, and these are the real issues, really. So thank you for your input. Thank you, Ronald. And now we are open for any questions. Some questions I've been dealing with as the presentation went on, but you may want to, Okala says I have some echo in the background. Okay, I think it's good now. Ismail says, let me see. Hold on, V2. Or maybe allow traffic with Renu and or other country not bandwidth is limited. So Ismail, actually, inter-Renu traffic is not limited. I hope most of us know this. So if IU Mbale is picking stuff from IU Kampala or Kaboja campus, that is not part of your subscribed capacity. That would be limited by your last mile link. If your last mile is fiber, dark fiber advanced, then you enjoy up to the capacity of the optics that you're using. Yeah, so inter-Renu traffic is not policed, yeah. Thank you for throwing light on speed test issues. You'll be getting less, I guess, less complaints. Caleb, thank you for that. Yes, why is the microwave backup not more trusted like the fiber cable? Okay, so of course, do you want to take that, Ronald? Okay, so the question is about, actually people answered microwave is usually affected by weather. Fiber, of course, also has different effects, but there are two different technologies. And of course, fiber in most cases is better, yeah? If you look at the loss per kilometer of fiber, it is low compared to the loss any wireless signal might experience. Wireless signals can experience absorption, diffraction, refraction. Many things can actually obstruct your wireless signal if you're getting the microwave link. Someone mentioned whether vegetation might absorb some part of the signal. Yeah, and of course, the other things that really come with it, the antennas. Really, if you're transferring the signal from between this antenna and this antenna, there's a lot that happens in the path. Okay. Yeah, someone says fiber is better because of the light technology. Yes, it's good to actually have a good appreciation of how some of these things work, so people know. Fiber uses light technology, the principle of total internal reflection. Light travels faster and all that. Okay, is the recording to be shared? Some of us joined late due to unavoidable circumstances. I think Ronald confirmed this will be shared. This is 1 minute. Okay, I think Martin was saying this is why many networks don't consider microwave. All right. If possible, why don't we do this practically together so that we can understand it better? Aguma Boniface asks. So Boniface, do you mean the presentation of this setting to be a physical one, or this like what Ronald just went through? Maybe we'll add on for us. Okay, so but we should also understand that some of these things like webinars, they should make you inquisitive to actually find out much more, than what you knew. When someone says something, and then you should get inquisitive to find out better. If now Ronald texts you about speed tests, maybe he didn't have enough time to exhaust everything. So, but can you go ahead to read on your own and actually get to appreciate it better? But of course, with some capacity building tracks, I think are going to be physical this year, maybe 1 or 2. Someone might correct me, but maybe not necessarily addressing these exact things that Ronald went through. But yeah, whenever we can, we really would be happy to engage you guys, and so that you can also engage us. I'm requesting for someone here good in documentation share their contacts with me. Okay, so Scovia has shared her number. Enren Spirit is sharing, but Scovia, if no one reaches out, be sure to write to noc@renu.ac.ug and someone will definitely give you a hand. Can CACTI application be worked on remotely from Renu if it is down? Caleb, I don't know if I understand your question, but maybe you mean that if you have your own CACTI for the institution, can we troubleshoot with you? That should be possible. If it is the Renu CACTI, then of course it's all on us. It's on us, since we just have a user interface. That would fall on us to actually look at it. Sarah says, thanks Patience and Ronald for this rich knowledge you have given us. Thank you, Sarah, for being present. Okay, let's see any hands up. Did I miss any questions? Okay, I am hoping we've been able to address all the questions you raised here. Can Ronald please throw more light on the higher bandwidth download and upload when using persona test? Ronald, you want to expound on that? Okay, please go ahead.
Persona is like, okay, it is an end-to-end device server. So why we have it having, like, from your computer or from your server or your machine testing against our Persona nodes, you are within Renu, the Renu network, which we said content, traffic, inter-Renu traffic within the Renu network is not capped. So you're only limited by your link capacity, by your equipment, your card, your network card. So if, for example, I don't know who asked, but if you run a test from your computer and your computer is able to do 1 Gbps testing against our Persona nodes, it should be able to give you higher, for example, higher than 100 or higher than what you subscribe for. So what you subscribe for is what we called the international capacity, which is capped according to the community, Renu community. We encourage collaboration. So we want to behave as one network. So it is important that, for example, Makerere University in Kampala communicates easily with Makerere University in Lira or Jinja. And at that point, you are only limited by infrastructure. So it should be running within the country and freely without any international capacity. So where the catch is, when you're going out of the Renu network, that is when we shall cap you to your subscribe capacity. If you subscribe for 100 Mbps, you'll stop at that. Even that is why on your speed test servers, you're going to look at what is available at that point. Thank you.
Okay, thank you, Ronald, for that. Gift Bafachi says, can Renu reduce my upload bandwidth capacity and add it to download if requested? So it's a discussion we had just as Ronald went about his discussion. This is not something that we have done with any of the institutions. I personally know that it's typically how satellite works for people that have ever used satellite. So you buy a different bandwidth for the download, different for the upload. But what Renu typically does is same upload, same up. And so if you buy, like I said, if you buy 10, you get 10 up, 10 down. But maybe this is something interesting we could look at and see how far we can get. Daniel said Renu should keep organizing more of these webinars. It gives opportunity to our teams to attend compared to other capacity building programs where participation is limited to 1 or 2 participants from each member institution. Thank you so much, Patience and Ronald, for sharing with us today. Thank you so much, Daniel, for being around and for this feedback. Kajumba says, then with this test, give insight on my network at that particular moment when I'm troubleshooting using Persona test. Okay, so I think this is further to your previous question. So I believe yes, because if you're getting funny results from Persona, which would be just from your network, I think this is this Busitama? Just to Renu, because that's like local traffic. If that has a problem, then certainly your international capacity also has an issue. So I believe, yes, this would point you to something Yes, Ronald, if you need.
Just something small, in addition to what Patience has said. When we ask you, we can usually send you speed tests results or tests, and then you also share persona tests. So, like Patience said, when your speed test results are too low, and yet your utilization is still low, you're not yet maximizing your capacity, there is a question. Then when you run persona tests and you still are struggling, say in the same magnitude as the speed tests, then, so if your persona results are funny or very low, and your speed test results are also low, so that means that this is actually affecting both your international traffic and your local traffic. And most likely there, it is a problem with your equipment, or either the configurations or something that is really local. Thank you.
Okay, thank you, Ronald. Wency says, my request is that the webinars should be of various expertise and mobilize specialists, I think, from various institutions. Yes, this is our intention. So this is a NOC webinar, but maybe sometime in there you may have another webinar on Renu services, different things really. So I guess that's the various expertise that you mean. Hakim says persona tests are the most confusing. Hakim, maybe if today's webinar didn't shed more light, we can take it on with you personally. Just drop us an email. Even you, okay. Yes, Hakim, so you can drop an email at noc@renu.ac.ug, and we could maybe take it on from there with you to help you understand it better. Kajumba asks again, is there any tool that can help view my LAN connections layout? Tool, LAN connections. Well, I think in Cacti, if you put in all your devices, you may be able to see how much bandwidth is on this distribution link, maybe even further to the access link. So I don't know if you mean stuff like that, but otherwise for the entire layout, you really have to draw it. Marion is thanking us. Oh, Kajuba meant diagrammatically. I am not sure of any. You might have to draw it. Actually, even Cacti itself has the other part of weather maps, but you have to feed in the information. Joshua says, I'm not maximizing my bandwidth and I still get slowness of internet. What should be the postbox problems? Joshua, could you write to noc@renu.ac.ug so that we handle this, as a separate ticket. Of course, this being a webinar and time running out, we may not really be able to get all the answers here. Scovia says we should also request to interact with the teams from different organizations for knowledge sharing and teamwork. Yes, I think that's that would be a good one. I think we would really encourage that. But I don't know what you suggest we do. Would it be Renu interlinking them, or would it be your organization reaching out to another member that is under Renu? Okay. Daniel says Nagios can give you a map layout at Kajumba. Yeah, responding to Kajumba. Okay. Hakim says, is it okay to share with us the bandwidth prices? Okay, so this is usually shared with ICT directors of all your institutions, And well, if you're one of them, I think you're able to get that. But also if you reach out, finance@renu.ac.ug, they might advise you on that if you need, but it's out there. We are happy to share with you our prices. But since you're already buying, I would imagine that, since you're already a member, I would imagine that you know the prices. But if you need, just write finance@renu.ac.ug. Yes, Wency. Yeah, guys, just anything to do with pricing, just write it to finance@renu.ac.ug and you will be helped. So it is exactly 5 p.m. and this is when this webinar is meant to end. Yes, thank you, Wency, for putting that there. So I want to thank you all for your active participation. Thank you for taking time. Thank you for making it interactive. Yeah, we hope to see you another time. Thank you and have a great evening.
Thank you, Patience, and thank everyone that have joined us. It's been an interactive session, and reach out to us. Our escalation matrix, for those that are still here, is shared in case you have any challenges with service, with performance, or anything. You have our contacts. The Renu Noc number is reachable 24/7. You can reach out to us either on phone call, on WhatsApp. And maybe one thing we didn't say, we have different platforms on which we communicate. Email, WhatsApp. We have groups that bring people together. We just expect that in case you're not in the group or anything like that, please reach out to us and we shall place you in the right group so that you get communication from the NOC and from our communications team and be on point on all the activities and programs that are running within the Renu network. Thank you very much. Would like to thank you for joining us. And when there are other webinars, we shall let you know. Thank you and have a good night.